This is question 1 from the June 2013 Unit 2 exam. So the question is a longer answer question, and it's about the safety rules for a bungee cord. It gives you 3 key rules: that it must not break when a mass of 130 kilograms is hung on it, that the mass of 5 meters of the cord is 1 kilogram, and the mass of the person jumping will extend the cord between 110 and 140%. It says that Lee has a mass of 80 kilograms, so which bungee cord would he choose for jumping? You have to use the information in the table to explain why you'd use this cord and not others. So pause the video here and take some time to re-look over the data in the question. So the first thing is that you can discount cord A straight away, because one of the key rules is that it must not break when you've got a mass of 130 kilograms hung on the cord. If you look at the minimum breaking mass in kilograms for cord A, it's 125 kilograms. Therefore at 130 kilograms cord A will break, so you can't use cord A. You also can't use cord D. This is due to the second rule. The mass for 5 meters of a cord must weigh 1 kilogram. You're given the mass for 10 meters of the cord, and 10 meters for A is 2, so if you've only got 5 meters of the cord, then it will weigh 1 kilogram. The same for B. 10 meters weighs 2 kilograms, so half of the length, 5 meters, will weigh half of the weight, 1 kilogram. C is also the same, so 10 meters weighs 2 kilograms, 5 meters weighs 1 kilogram. But D has got a mass of 3 kilograms for 10 meters, so 5 meters would weigh 1.5 kilograms, so D is too heavy. So we're left with C and B for our options. So we're going to have to use the final rule to be able to decide between B and C. So the final rule states that the mass of the person jumping will extend the cord between 110 and 140%. So Lee's got a mass of 80 kilograms. So it's 80 kilograms. Cord B will extend by 150%. So that's outside of this range here. The range says 110 to 140%. 80 kilograms stretches it by 150. So we can't include B anymore. So our answer must be C, but let's just double check that. So at 80 kilograms, we are looking at a stretch bigger than 100%, which is right because that's at 70, but smaller than 150%. So we'll assume that it's somewhere in the middle. I guess you would assume that it's part way between those. So you'd be looking at a stretch of about 125%, which is between these two percentages here. So let's check out the mark scheme to see how you actually get the marks there. For full marks, you have to choose the correct chord, which is chord C, and you have to have stated an explanation for all of the chords. So it says all chords and all properties are considered in a logical order and include relevance of the weight extending chord B by more than 140%. Okay, for 3 or 4 marks, then you could have chosen B or C, and you've referenced at least 3 of the chords, so you might not have considered one of the chords. So the points that you can consider are these over here. Like we said, we discount chord A because it breaks below the mass needed. We would also discount chord D because of the weight of it. So chord D is too heavy. We said it was 3 kilograms for 10 meters, which is 1.5 for the 5 meters. And then this point here discusses the stretch of B, that B stretches too much. 80 kilograms would extend it for 150%, which is over the range asked for, whereas chord C hits it in the middle. Part B is very straightforward. All you have to do is put the numbers given into the equation that's given here. So it says the number of chords, which is what you're being asked to work out, is the mass of the car. The mass of the car is 1,200 kilograms. times by 2 divided by the mass needed to break one cord. So if we look back at the information in the table, so for cord C, the mass needed to break the cord was 250 kilograms. So we put that into the equation. So here we go, we've got 1,200, that was the mass of the car, times by 2 divided by the breaking mass of the cord, which is 250. Now that actually equals 9.6 cords, and obviously you can't have 0.6 of a cord, therefore you would use 10 cords. You'd always go up in this situation because you'd need to have it stronger rather than weaker. So part C, you're given the mass needed to break a different bungee cord, and there's 5 pieces of cord here that's been tested. One of these is the outlier. Hopefully you can see that that's the third piece of cord here, breaking mass of 256. But the students unusually decide that they shouldn't discount this as the outlier. So why are they not going to discard this? Normally you'd get rid of an outlier. Well, in this case, it's about safety. This is the lowest breaking mass, and it's really important that if any of the cords are going to break at a low mass, that you actually show that, because you've got to show the lowest breaking mass. If not, you might end up with one cord that breaks lower than the rest, but you wouldn't know if you've got that cord or not. So the mark scheme points that out. It says that value is the minimum break-in strength, so that's your 256 kilograms, and so it's important for it to be there for safety reasons. Okay, the students then test pieces of the same cord after it's been flexed and stretched a number of times, and the results are shown here along with the mean. The students compare the results to those in part 1, and they agree that they're different, and then they all give reasons why they're saying it's different. So it asks which students has given the best reason for deciding that the results are different. Well, if you're looking at different data, then you need to either have the ranges not overlapping, or you need to have a mean from one set of data sitting outside the range of the others. So the only one who comments on that is Barry. So Barry says they're different because the means of each set lie outside the range of the other set. So if we look here, the mean for the set of ropes that have been stretched and flexed a number of times is 249, and that sits outside of the range. Here the lowest one was 256, so 249 is outside of the range, and the same with this one. The mean before it's stretched and flexed is 271. If we look down at the bottom set of data here, the highest is 269, so 271 again is outside of the range. So both of the means sit outside of the range of the others. The final part of the question says that the students explain why the mass breaks once it's been flexed and stretched many times. The logical reason for this is obviously that it's going to weaken part of the cord, but let's check out the others as well. So it says A, every cord is different from another. That's true, but it doesn't explain why they're all weaker afterwards, after flexing and stretching. Flexing and stretching strengthens the ends of the cords. That wouldn't be true, because if that was the case, then they'd be able to hold heavier weights, and they broke at a weaker weight. C is the correct one. Flexing and stretching weakens parts of the cord. And D, the flexing and stretching changes the thickness at the ends of the cords. Well, I don't know why that would be the case. It doesn't do this. So C is the correct answer here.